All right, hi there. My name's Andy. I'm an engineer who is particularly interested in the topic of technology transfer. And I wanted to start making a video series about it because I thought that people don't really talk about it a lot in the whole entrepreneurial community. There's not a whole lot of people that even know this kind of stuff exists. So I thought that given I have a little bit of background in it, especially having worked on it for a number of years at a couple of universities, I thought I wanted to bring it to the attention of more potential entrepreneurs and technologists that want to work on this kind of stuff because it really is, at least to me, very interesting. And I love like researching it and doing those kind of things. So I figured that what better way for me to have an excuse to do that than to put some sort of video up that I can then refer back to in the long run, or people can get some sort of use out of, or maybe it actually even inspires people to go do stuff like this themselves. So what is technology transfer? So in this case, I guess there's two different definitions, one of which is whenever countries or companies give each other access to different technologies as part of some sort of like trade agreement or something. The version that I'm talking about is the idea of taking patents and research that was developed originally normally at a lab, like a public lab or at a university, and making it out into the real world. So there's normally two different ways that that happens, one of which is through licenses to large corporations. So IBM could go to a university and say, hey, I want to license this fancy new server technology from you. But the side that I really like and the side that I've worked on for a number of years at this point is the startup side. So theoretically, you as an individual can go to university and say, hey, I'm really interested in this technology. I think it has a lot of potential, and I want to see if I could come up with some sort of business plan around it. And then you go through a whole process where you license it, and you do research on it and that sort of thing. But basically, the idea is that you take a technology that has been sitting in a university lab for however long and build a product and potentially a business around it. Part of the reason why I like this is because there's so much of it to go around. Um, there's a concept called R1 research universities, which I'll talk about a little bit in the near future whenever I'm trying to do the next step in this process. There's about 150 of them in the US, and I think the standard requirement is they have to have more than like $1 billion in research funding a year. And in my experience, the medium to large size ones have something like 150 to 200 patents issued to them every year. And so you're looking at, upwards of 10,000 different technologies that are patented by universities every year. Even if, 1% of that is acceptable to build a startup around, you're still looking at 100 startups a year just around technology transfer from universities, right? So I really get excited about this kind of stuff because some of them are like, wow, that's a really cool idea, and I think that should exist. And I I really think that people should be more aware of this because I don't feel like people are. They're just sitting on these various websites and no one really knows anything about them. Everyone I talk to about this concept is like, I have no idea what that is. And all sorts of you know, uh, those educational pathways don't really seem to be there unless you happen to be in a university doing this kind of stuff. So what I'm going to try to do is come up with a randomizer of the 150 whatever R1 research universities, and every week for at least the foreseeable future, I'm going to pick three of those from a randomizer. Have that randomizer pick three of them for me, and then go through and try to find one interesting technology from each of those universities because pretty much all of them have something that's interesting. So I'm going to here and come back with a screen that will show what university we'll pick for this week. All right, so I did a little bit of messing around and realized that I can just use AI to sort through a list for me. So I'm gonna use Gemini because why not? I'm sort of a Google fanboy and it's just as good as anywhere else. So I'm going to say, please pick three random things from this list, and I'm going to copy the list of all the R1 research universities that I literally just copied off Wikipedia. So let's see what they come up with. Brandeis, UC Santa Cruz, and Clemson. All right, that's a good place to start. All right, so let's start with Brandeis because I thought this one was particularly interesting. So they had a number of technologies, and I should say I normally trend towards physical products and not so much the biological side because my training is in electrical engineering. And I feel a lot more comfortable with those sorts of physical products rather than the fancy biomolecules that a lot of places have. So you'll find the ones that I'm particularly interested in are normally along those lines, but there's just as many, if not more, of the fancy biological ones, and I'll try to represent those as well. I just might not know as much about them. I thought this one was interesting because my kid is currently in swim team and he's not special needs or has arthritis, but I can certainly understand having my own experience on a swim team, how difficult it is to get a swim cap on. So apparently, they're the inventors, Rebecca Sokoloff, I guess is how you would say her name, at Brandeis came up with a swim cap that, if you can see down here, has some hooks on the side of it. So apparently they got a patent for it. This is number 10 million, whatever, here. That is basically a swim cap that is easier for old people and people with special needs to put on. I think that's interesting for a lot of reasons because I don't think it's necessarily just old people and like people with arthritis or people with special needs. I know a ton of kids that also struggle with this. My son goes and has his coach put his cap on a lot of the time, as do probably half of his teammates. So I thought this was a really elegant solution to a known problem that is very simple and they have a patent for. So this is exactly the kind of example of things that I'm like, why did I not think of this? Wonderful question. I swam competitively for more than a decade and never even considered trying to solve how hard it is to put on a swim cap. But, I'm not sure if, is this just a modified Speedo? That's a modified Speedo cap. So I guess it's not clear whether, I guess we can look a little bit at the patent itself here. So the patent itself, oh, it's on the inside. That's interesting. So you can see here, this looks almost like a football helmet, but there's a strap inside of it where you pull it down with the rings that way, and then it still covers up. That's really interesting. I wonder how comfortable that is. But I guess, as with all of these things, you a lot the good universities have links to the patents and links to here's what you can license and that sort of thing on it. So obviously Brandeis does that, but this is a really interesting, very simple thing that I'm guessing they just need somebody to come and say, yeah, that's kind of cool. I want that. Uh, you could literally sell millions of these things. I could easily see that happening. In any case, that's the first one of these. Good job, Dr. Sokolov. That's a brilliant idea.
So next up, we have UC Santa Cruz, which is inarguably the university with my favorite mascot. If you don't know what UCSC's mascot is, feel free to go look it up. But one of the things that I think has been a theme of a lot of the projects that I look at, or a lot of the technologies that I find, is a, I guess it has to be placed in context. So a lot of them tie back to something else in my life. So you'll see, this is an example of one that is the case for. So in this case, it's for a technology for an advanced potentiostat, which for those of you who don't know what a potentiostat is, it is I'll call it a fancy electrochemical sensing tool. So basically, it's used in a lot of research, but also it happens to be the basis of a technology that I was working on for a number of years. And that this exact thing, I think, would have actually solved one of the major problems that we had with it. So it has multiple channels. A lot of potentiostats, they basically control voltage and currents uh, directly, and a lot of them have like a single channel output. This one is apparently a multiple channel output, so you can stack them literally on top of each other to create 8 or 64 up to 64 channels in a potentiostat. And a lot of like drug discovery and those sorts of things uh, that could be really helpful. I don't know if this exists elsewhere. My assumption would be that it does, but if it doesn't, I can absolutely see a use case for something like this simply because I literally could have used it on a project that I was working on for a while. So again, there's a patent here from 2023. Let's see, you know, a whole bunch of things, including claims, a base printed circuit board, all sorts of fun stuff. So I don't know if you can see this, but this looks like a very badly drawn picture of some stackable boards. I don't know what exactly that is. In any case, details about the stuff here, or the, what do you call it, technology here. So, in this case, it doesn't seem like UCSC says who the inventors are, but if you really want to find out, you can normally do something like this, and you wind up searching for advanced photonics. Oh wait, actually, I bet you it says who it is on patent. So in this case, it is, wow, Padawang Pensati, Mircea Teodorescu, and Marco Rolandi are the three people on this patent. Uh, so this is actually, again, relatively new. It's signed in 2023 last year, meaning it has like 16 more years left on that patent. I mean, if you're interested in learning more or working more in electrochemistry, I can absolutely see a use case for this one. So next up, I believe we have Clemson. All right, so I think this was an interesting one from Clemson. So this is the methods to convert non-edible, non-packageable, packable, non-packable, and highly spoiling parts of fruits and vegetables to a nutrient-rich fine powder or flour. So instead of a like standalone technology, this seems like it's more process. But I was really interested in this for a couple of reasons. So first things first, going back to the idea that a lot of times I'm drawn to technologies that solve a problem that I have in my life. And lately I've been on a smoothie kick. So I go to Costco and buy a bunch of bags of frozen fruits and vegetables in a package and then dump it into a blender, add some apple juice, and poof, I have a smoothie. But one of the things that annoys the heck out of me when I'm doing that is a lot of times the fruits and vegetables getting chopped up in the blender are not particularly uh, it doesn't make it easy to blend. Let's put it that way. So, my Vitamix blender is perfectly functional and works well, but it seems to me like there would be a better way to do this. Also, they have to be stored in the freezer. This seems to solve all of those problems. So basically, it's a way of taking fruits and vegetables that would otherwise be too ugly to be sellable, and there's a whole thing around that we can talk about in a second, but makes it into a nutritious powder that you can then pour into a drink or something equivalent to it that allows you to get the nutritional benefits of the fruits and vegetables without necessarily having to deal with the storing of them. So in this case, they turn it into a micronutrient-rich powder that basically you dump into some water or apple juice or whatever, and you are able to get all the nutritional benefits of getting full servings of fruits and vegetables without any of the hassle. Um, Down here, it talks a little bit about the process and then also some advantages. So, they say things like freeze drying, spray drying, all that kind of stuff. They are, and I agree with this, very capital intensive and it's difficult to scale. But, the argument here is that this is extremely easy to scale. I'm not sure how valid that is because there's not a whole lot of details about what this technology actually is. And as far as I can tell, there is not a link to the patent or anything. Also, if there's something I thought was interesting, the inventor, so Dr. Dil Favarunha, I hope I'm saying that right, has the same last name as the technology manager. So Push Para, oh man, I'm going to butcher this name. Pushparaha, Pushparaha, Savaraha. Okay, there we go. Sorry about that. But that's interesting. You normally don't see the same last name in the inventor and the technology manager, so I'm wondering if they're related. In any case, one of the things that I know made a big splash in the business world a little while ago was this the push to um, find or utilize like non-perfect foods. And this is another excellent use case for that. So instead of like, having a pepper that has like a weird thing on the side of it that makes it so it's not sellable on a supermarket shelf, you could just like turn it into a powder and get the same nutritional benefits as you would from actually eating that pepper. Um, I'd be very interested to see what the process of this is and how it says it's TRL 4.5, which is actually pretty high. And also would imply that they've tested it before. So I'd be kind of interested to see how this would work. And again, the business model here seems to be more around the uh, overall process rather than the individual technology of doing this. But in any case, seems like a really interesting idea. And so that also is the three technologies that I wanted to go over for the week. So again, I'm just going to do this for my own self because I really enjoy researching this stuff and talking about it, and it comes up with some crazy ideas that I would never have had a reason to find anyway. But hopefully, you guys enjoy this. If you got any feedback for me, feel free to leave a comment and subscribe. And I will see you guys next week with some more interesting technologies that might someday become reality. Thanks a lot.